Welcome. So in this video we will learn about a equipment which is known as Rancimat. So Rancimat is the accelerated oxidation test used to determine oil stability index or induction period of any fatty product. So this is the equipment Rancimat, where we are determining the oil stability index, induction period, and in turn the shelf life of any fat containing products. So this equipment consists of two heating blocks. So one heating block is here and second heating block is here. Okay, and then we have reaction vessels. We can see that here reactions vessels are there, where we are keeping the sample at the weight of the sample should be optimized for each category of sample. So generally we take 3 gram, 6 gram or 9 gram of the sample here in the reaction vessels. So these are the reaction vessels, and these are the measuring cylinders, the measuring vessels, which contain 60 ml of deionized water. Okay, then here we have the silicone tubing. You can see that here these are the silicone tubes there. So here from the since we are providing the accelerated conditions, so your volatile acid, the secondary oxidation product, will move from this silicone tube to the water. And this is the conductivity electrode is there. This electrode is the conductivity electrode, and here we can see that 8 sample can be analyzed simultaneously. 1 2 3 4 and 4 here, so total 8 samples can be analyzed. There are 2 heating blocks, so 2 temperature can be used simultaneously. Here we are getting 130 degrees Celsius, here we are getting 120 degrees Celsius, so higher temperature we are keeping. So 2 heating blocks are there, so 2 temperature can be applied to the sample simultaneously. And then for a single PC there is 4 Rancimat can be connected. Okay, so just to tell you that this is the equipment of Rancimat, and with this equipment is used to determine the oil stability index or the induction period, and in turn the shelf life of any fat containing product. And it consists of measuring vessels, and it consists of reaction vessels where the reaction will occur. And then in this we are providing the accelerated conditions, that is higher temperature. High temperature we can apply temperature can go as high as 110 120 degrees Celsius, 130 degrees Celsius. And of course that manufacturer has given that the temperature can be adjusted to 50 to 220 degrees Celsius. We can adjust the temperature in the heating block. We can produce this much temperature. So increased temperature and increased airflow rate, so we are providing the increase, say 15 ml per minute or 10 ml per minute or 20 ml per minute. Okay, so increased airflow rate will be there. We are providing the increased airflow accelerated condition. One is increased airflow rate and higher temperature, so that the oxidation will take place faster. So if you keep the sample, so if you want to determine the sample the shelf life of any fatty containing product, we have to store it for a long period of time until the changes happens in the density parameters. So long time we have to store to predict the shelf life. लेकिन हम Rancimat से कुछ ही घंटों में हम ये पता लगा सकते हैं कि किसी भी फैट प्रोडक्ट की कितनी सेल्फ लाइफ है. तो अगेन रिपीटिंग दैट Rancimat is the accelerated oxidation test to determine the oil stability index or the induction period of any fat containing product, and in this we are providing the accelerated condition to the sample so that oxidation happens faster. So their formation of primary oxidation products will happen, and the primary oxidation products are the peroxides and hydroperoxides. Peroxides and hydroperoxides are there, and then we have secondary oxidation products also, which includes aldehydes, ketones, alcohols, and some volatile acids. And these secondary oxidation products will move from this silicon tube to this measuring vessel containing 60 ml of deionized water, and conductivity of this water is continuously monitored, and there is a graph will be is plotted between the conductivity and the time. So here we can see that here if we can take the conductivity here on the y-axis, and here we can take the time. So we'll see that as the time progresses, the conductivity of the water increases, and there will be a time when the conductivity rapidly shoots up, and this time is nothing but the induction time, induction period. More we will cover in the coming slide, but just to tell you that conductivity of this deionized water is continuously monitored using this conductivity cell, and there will a time will come when the conductivity of the water gets shoots up, and this time is known as the induction period. So induction period, two way we can define that. Induction period is the period during which all the antioxidants present in the system get consumed and the oxidation just starts. And second way, in this Rancimat, we can define Rancimat in the time during which time at which the conductivity of the deionized water shoots up or rapidly increases. That point, that time is known as the induction period in the Rancimat. Okay, so we will cover it one by one, but just to give you a brief overview of the Rancimat. So this is the equipment, and this is the basic principle which is shown on the slide. So let me again repeat it. So here this is reaction vessel, here it is written reaction vessel. We will take sample in the reaction vessel. It may be 3 gram, 6 gram, 10 gram, 9 gram we can take, and then we have to optimize the quantity of the sample to be taken for each type of sample. And then heating block is there, where we are applying the increased temperature, higher temperature, 110, 120, 130, as I already told you. This is a conductivity cell is there, which is measuring the conductivity, and then we have measuring vessel which is containing 60 ml of deionized water we are taking. Okay, then here the conductivity is being monitored by the conductivity cell continuously, and so what is happening, graph will be plotted between the conductivity and the time. So in this the induction period, a time will come when the conductivity of the deionized water shoots up, and this time is nothing but the induction period. So induction period is the period during which all the antioxidants present in the system get consumed and the oxidation just starts. Is the period at which the conductivity of the deionized water in the measuring vessel shoots up. That is known as the induction period. So at different temperature we will be determining the induction period. Say here the if extrapolation software is there in the Rancimat, and say we know that say we are using 3 temperatures. Say here we can see that 130 degrees Celsius we are obtaining some induction period. Some time will come 120 at some induction period will come 120 some induction period will come, and say similarly 100 degrees Celsius some induction period will come, and we can extrapolate it to 20 degrees Celsius. And this is extrapolated using the equation which is the Arrhenius equation. So here we can see that this is the Arrhenius equation of this type will come. So value of A has come, B has come, R square is this much, and then this is the induction period which is in years it is 1.19 in years. At 20 degrees Celsius we have extrapolated to 25 degrees Celsius. This is the meaning, and number of determination, how many determination has been done, that is the 8 determination has been done. And then a standard factor which is nothing but that Q10 value, that is the rate of the oxidation is doubling almost with 10 degrees Celsius increase in temperature. That meaning this is the temperature coefficient or the Q10 value. So this way 2 graphs will be plotted, and ultimately we will have the shelf life of the product extrapolated. Okay, so here this is logarithmic. See, this is log of induction period, and here it is the temperature. So this graph between the temperature and the log of induction period, this is logarithmic scale actually, and this is the difference between that graph between the conductivity and time. Okay, now we will see one by one about the basic of the Rancimat. So Rancimat consists of modern computer controlled analytical instrument. Is an instrument for determination of oxidative stability of oils and fats, and thus their shelf life. Ultimately we are predicting the shelf life of any fatty product. Now it is the accelerated oxidation test, wherein we are providing the elevated temperature I have told you, and also under the exposed air of condition, that is increased airflow we are providing, so that the oxidation which otherwise would have taken years to complete will be completed in a couple of hours, and we will able to obtain the induction period of the fat, and ultimately the shelf life by extrapolation software, as I have told you, to determine the oxidation or the induction period of any fatty product. Now faster oxidation in a few hours will happen instead of weeks or months for different kinds of samples. Now this technique was initially developed by Hader and Zurcher in 1974. Now oxidative stability is the important criterion for evaluating the quality of oils, fats and biodiesels. Okay, this is automated and time saving. The equipment is automated and it is also the time saving. Now the method has been established and has been included in various national and international standards. So AOC, CS, ISO also have included this method for determining the oil stability index or the induction period or the shelf life of any fat containing product, adopted by the international organizations also. Now lipid oxidation in foodstuffs is one of the most important critical factor affecting major quality products. So color will be affected, flavor will be affected, aroma and nutritive value, because there occur destruction of essential fatty acid, destruction of fat soluble vitamins will happen, decrease in the caloric content will happen. So ultimately nutritional quality will get affected, shelf life of the product will be affected, and competitiveness of the product will be affected. So it reduces the shelf life and influences the suitability for its consumption. It has a greater importance in food industry to predict the shelf life of foods, especially fat-rich foods. Now, determination of oxidative stability at room temperature is tedious and time-consuming process. As you know that if you want to determine the oil stability index or the shelf life of any fat-containing product, you will have to keep it for a long period of time, because they are having long shelf life, and so this is a tedious process. So that's why accelerated test like Rancimat has come into the picture. So it is necessary to use an accelerated test to obtain the oxidative stability in a short period of time. Now there are earlier several accelerated methods have been described, like scale of 1 test is there, active oxygen method is there, and now Rancimat is there. Now the active oxygen method and the scale of 1 test, they produce comparatively less reproducible results and are time consuming methods. So they are less reproducible and also they are time consuming methods. So that's why Rancimat has become comparatively popular, because it is easy to handle. There is reproducibility there in the results. We don't require any organic solvents during its run, and there is continuous measurement happens requiring no periodical and nickel information. So it can be kept unattended also once the equipment is started. Now if you see some of the features of the Rancimat, that is the automatic control instrument, easy to operate, it is very easy to operate, conversion of induction time to other temperatures, extrapolation to predict the shelf life of the sample. So as I already told that at any temperature, if you want to predict the shelf life, say 20 degrees Celsius, 30 degrees Celsius, 40 degrees Celsius, you are initially accelerating the conditions to have the oxidation in a short period of time, and then you are extrapolating to have the induction period at particular temperature. So it is having excellent data security and reproducibility. So results are reproducibly every time you can have the same results. There is time and money saving is there. Obviously so much time has been saved, and then not much equipment is there, only the initially cost of the equipment. Otherwise no major consumables are required for the equipment. Evaluation can be done at 2 different temperatures simultaneously. As I've told you that there are 2 heating blocks which are there in the Rancimat. So 2 temperature at simultaneously we can analyze the sample. So independent heating blocks have individual start of each position. Even the timing also can be changed. One heating block no need to the starting temperature for both the heating block may be different also. That is the meaning. Now let us see working principle, which I have told you, but here it will be more clear to you. The method is based to the measurement of the conductance produced by volatile organic acids collected in the deionized water. So the secondary oxidation products through the silicon tube are entering into the deionized water, where the conductivity is monitored. So during the measurement, a stream of air is passed through the sample. Stream of air to provide the increased airflow rate with 10 ml per minute, 20, 50 flow rate we can provide, and the sample contained in a sealed and reaction vessel. Okay, now these conditions like increased airflow rate and the higher temperature will accelerate the rate of oxidation of the sample. So with peroxide being initially formed, so initial oxidation product will be your peroxides, and then peroxides and hydroperoxides, and these ultimately will get degraded to secondary oxidation products, which include the aldehydes, ketones, alcohols, and the volatile acids. That is low molecular weight organic acids will also produce in addition to other volatile organic compounds. So these are transported in a stream of air to a second vessel which is containing the distilled water. That is nothing but the measuring vessel. Okay, so conductivity in the vessel is recorded continuously against time, so that conductivity is being monitored continuously against time. So a graph is plotted between conductivity and time, which can be used to estimate the induction time or overall stability index of oil, thus predicting the shelf life of the sample. So a time will come when the conductivity of the deionized water will get shoot up, and that time is known as the induction period. So there is two ways to define induction period. One is induction period is the period during which all the antioxidants present in the system get consumed and the oxidation just starts. And second way is to define that the induction period is the period during which the conductivity of the deionized water, at which the conductivity of the deionized water, because of the secondary oxidation product that has been produced, shoots up. Okay, it suddenly increases. So the graph we have already seen that the conductivity of the water suddenly shoots up. This is known as the induction period. Induction period, the time required to reach an end point of oxidation corresponding to either a level of detectable rancidity or a sudden change in the rate of oxidation. So sudden change will be there in the rate of oxidation. So OSI, that is oil stability index, or the induction period, it correlates well with the stability of the fat and the various condition of the lipid. So it has been reported that induction period of the oil stability index, it correlates well with the stability of the fat and the various conditions of lipid oxidation. Now, prediction of shelf life of fatty atom is possible by plotting the graph of the logarithm of OSI versus elevated temperatures and extrapolated to room temperature. So I have told you that the induction period that has been obtained at higher temperature can be extrapolated to room temperature, that is lower temperature. Now, temperature, that is Q10 number, can also be denominated. What is the Q10 value? That is, if we are increasing the temperature by 10 degrees Celsius, how much is effect on the reaction? So how much is the effect on the reduction period? That it will reduce. So obviously it will get reduced. So Q10 value for generally this Rancimat also is generally 2. That is, the induction period reduces to half if you are increasing the 10 degrees Celsius temperature. So it predicts the increase in the oxidation rate with 10 degrees Celsius increase in the temperature. Okay, now if we see some brief discussion, we see that heating block, the model 743 Rancimat has 2 independent heating blocks that allow up to 8 samples to be analyzed at 1 or 2 temperatures. So I've already told you 2 heating blocks, 8 samples can be analyzed simultaneously. 2 heating blocks are there. So reaction vessel, I have told you. So reaction vessel looks like this, and weighing out the sample and assembling the reaction vessel is extremely simple and safe. Here we are keeping the sample. So here here ghee sample has been taken. We can take 3 gram, 6 gram or 9 gram, and we have to optimize the amount quantity of the sample to be taken for each category of sample. Then we have the measuring vessel also. This is easy to clean. Polycarbonate beakers are there. These are made up of polycarbonate, are used for the automatic conductivity measurement. So here we have the conductivity probe will be there, and then the deionized water will be there in this measuring vessel containing 60 ml deionized water, and glass beakers are available as alternative also. So if measuring vessels are not there, then glass beakers can also be used. Now coming to conductivity cell. So conductivity cell, here we can see that this is the conductivity cell and having the cell constant of 1.1 centimeter inverse plus minus 0.1. This is having the cell constant. Now this conductivity cell is immersed into measuring vessel which contain glass distilled water. So deionized water it should contain, and told you that 60 ml deionized water it will have. And other connection we see, in order to make operation as simple as possible, there are no controls are there at all on the instrument, and all its functions are controlled from the PC itself. And apart from power switch, the only feature you will find an instrument on the instrument are the RS23 socket for the connection to a PC. So here you can see RS32 socket is there to connection to the PC, and a socket for connecting the Peltier 100 temperature sensor. So here you can Peltier temperature sensor can also be connected to monitor the temperature, to calibrate the temperature. So we have a air inlet filter is also there, and molecular sieve is also available. Why? Because air used for the measurement is aspirated through a filter. First it passes through the filter, and that prevents the particles from entering into the instrument. So any impurities should not enter into the vessel. For ensuring the same, we have filter, and molecular salves are also available that removes water vapor from the aspirated air, as water contributes to the hydrolytic composition of the fat. So if anyhow water will reach to the sample, then hydrolytic rancidity may happen. So to prevent that, we are make use of the molecular sieve, which will remove the water vapor from the aspirated air, so it could interfere with the measurement. Now, how to clean the components? So once your analysis has been completed, you have to ensure that thoroughly all the components which are used during the analysis should be cleaned. So vigorous cleaning is required after each run to avoid contamination that can catalyze the peroxidation. So measuring vessels to be cleaned with ethanol or 2-propanol. Do not use acetone. Measuring vessel covers are there and electrodes are there, that those also to be cleaned with acetone and or 2-propanol. Reaction vessel is there, that has to be disposed. So once it has been used, so it is better to dispose them. Air tubes also to be disposed after use. And then the reaction vessel covers are there, that are to be washed with acetone or 2-propanol. And silicone tubing, that is transporting the volatile components from the reaction vessel to the measuring vessel, that also to be cleaned with acetone or 2-propanol. Now if we see what are the factors which affect the temperature explanation, or what are the factors which may give the erroneous result. Most important factor is temperature, because we know that 10 degrees Celsius increase in temperature causes 50% reduction in the induction time, and maximum deviation of temperature should not be more than 0.3 degrees Celsius, and stability of the temperature should be less than 0.1 degrees Celsius, and exact temperature adjustment is very critical to have the accurate results. And gas flow is also having small influence, but major influence is by temperature only. So no change within 10%, plus minus 10% flow change is there, then no effect has been observed on the results. Then you have sample weight. It is also having the small effect, that but it has to be optimized for different category of the sample. We have to ensure that there are sufficient saturated air conditions are there, and then there is no escape of air from the sample. That is, if more turbulence is there of air, then air will escape rather than causing the oxidation of the sample. So we have to optimize the sample size and the airflow rate. Okay. Now prediction of oil stability, as I have told you that we can extrapolate the oil stability at any temperature. So induction time increasing by factor approximately 2 if the temperature decreases by 10 degrees Celsius. So this is Q10 value, that is Q10 values of this reaction is also 2. The Rancimat software offer the extrapolation. So in the software itself, extrapolation can be done, and using extrapolation data can be directly extrapolated to selected temperature, say 37 degrees Celsius. In this way, it is possible to estimate the storage stability of different products. Now, so this is the extrapolation software I've told you. So on the y-axis we'll have the temperature, and on the x-axis we have log of induction time. So this is logarithmic scale, and say here 130 degrees Celsius, some induction period will be there. At 120 degrees Celsius we will obtain some induction period. 110 we will obtain some induction period. 100 degrees Celsius we will obtain some induction period, and then we will extrapolate it to say 20 degrees Celsius. Here it is given that it has determined in 20 degrees Celsius. So equation of this Arrhenius equation will come. This is the Arrhenius equation. This is the same form as you use, k equal to a minus a e to the power minus ea by rt. So this is the same form. This is Arrhenius equation. Okay, so a value here coming, b is coming, r square value will automatically come, and then induction period is 1.19 years at 20 degrees Celsius. So 8 time determination has been done, and then the Q10 value is 2.162 is obtained on the software. Okay, so change in induction time per degree Celsius, that is the temperature coefficient. So this is the extrapolation software which is there in the Rancimat. So theoretical value is generally is for this type of reaction is 2. and this is the estimated shelf lifetime, that is 1.19 years. Okay, now if we see some of the applications of the Rancimat is used to predict the oxidative stability or shelf life of pure edible oils and fats obtained from plants or animals, and it is also used to determine the oxidative stability of natural fats and oils from foods or cosmetics after extraction with the petroleum ether. So if we natural fats also we can determine the oil stability index that can be extracted from the fat. And then antioxidant research, if you want to compare the different antioxidants, so which one is having maximum efficiency, antioxidant efficiency, we can determine using Rancimat. Say for example, a sample is having BHA and other BHT, say other TBHQ, different antioxidants are there, and with the antioxidant which will have minimum induction period for the sample, that is if it is incorporated in the same sample, say we are incorporating in a ghee sample BHA, BHT and TBHQ, so one which is having a lower induction period will be having the minimum antioxidant efficiency, that is obvious. So TBHQ, since this is the strongest antioxidant, so it is expected that induction period will be higher in this case, because it will prevent the oxidation. Okay, now oxidation of FAME, also fatty acid methylation, mainly used in biodiesel industry. So metrom is most widely used in the biodiesel industry, and oil stability index of light heating oil with copper catalyst can also be determined. Now for animals fats and oil, if you want to predict the shelf life of butter, fish oil, lard and different animal fats and oil, that can be done for determine the oil stability index of vegetable fats oils like soybean oil, sunflower oil, coconut oil, peanut oil, palm oil, that can be done. And fat oil containing products like direct measurements can be done for margarine after extraction of fat from meats, nuts, biscuits. So this is very popular in biscuit industry also. So Nestle is using this equipment to predict the shelf life of the biscuits. And then we have antioxidant research. I have already told you that we can compare the antioxidant efficiency of different type of antioxidant. Maybe we compare natural antioxidant with the synthetic antioxidant, which one is having maximum antioxidant efficiency. That can be easily be done, because obviously if the antioxidant is strong, then induction period will be higher. So a antioxidant which is giving a higher induction period for a sample means he is having the higher antioxidant efficiency. So this was about the basic of Rancimat, what are its application, what is the principle of Rancimat, and how the equipment works, that we have discussed in this